The yield V in millions of cubic feet per acre for a forest at age 2 years is given by the following function. So you're going to graph this function at some point if you want. Determine the horizontal asymptote of the function. So you're trying to figure out, well, what happens when t goes, that's the wrong color, t goes to infinity. As t goes to infinity. So if t goes to infinity, it looks something like this. It's v equals 6.7 e to the minus 48.1 over a really large number. So a number over a really large number, anyone know what that is?
Pretty much 0.
0. And what is e to the 0?
1.
1. So this is like 6.7 times 1. So the answer here is that this goes to 6.7, that first number there. So if you graph it, I don't even know what it looks like when you graph it, but you will see that there, it approaches that horizontal line there. We can graph if we need to later on. Interpret the meaning of the horizontal asymptote in the context of the problem. So the yield, I believe it's this one. It's usually to give you the answer and then like try to figure out why it's correct. The yield will approach this many millions of cubic feet per acre. It's the y value that it approaches. In this case, the y is v, and v is in millions of cubic feet per acre. It does it at infinite years, but that's not what's going on here. So find the time necessary to obtain a yield of 1.6 million cubic feet. That's setting v equal to 1.6. And this can be done by hand up until the calculator step. So we're going to first divide by 6.7. And then to undo e, use ln, and natural logarithm. So take the log of both sides, and the result of that step is you get minus 48.1 over t. Whenever you have t in the bottom over here on the right, it can actually swap positions. You can actually just swap these. That's pretty helpful here because that tells you the answer right away. So t is minus 48.1 over natural log 1.6 over 6.7. So if you got a calculator handy, go ahead and see what you come up with for that. You can also graph this and find the intersection. So I get 33.6. I don't know how many, what did it say to round to? 3 decimal places. That's not going to be right. 587. 587. So that's your answer there for part C. And if you had any questions on this, let me know in solving it. Do you want to do this graphically also, or is this by hand okay?
I think by hand is perfect. Thank you.
Okay. All right. Okay, so let's jump to another question here. Let's jump to a new laptop that's sold. I don't know what question that is, but it doesn't have a question number. I'll just snip that in. And all right, here we go. All right, find okay, so new laptop computer that's sold for $12,000 in 2005 has a book value V of 475 after 2 years. So they're giving you two ordered pairs. They're telling you that the value, which is Y, they're giving you time, comma, value. And sometimes it's good to write that out just to make sure you get the data points down. So time 0, it's $1,200. And after 2 years, it's actually worth 475. So the linear depreciation model, they're essentially just asking you to write the equation of a line here. So I'm gonna do y equals mx plus b because I have the b value. The slope is 475 minus 1200 over 2 minus 0. So your linear depreciation model, and I think you got to enter all of this. Let me get that number. 475 minus 1200 over 2 minus 362.5 x plus 1200. But I think we have to do it in terms of the variables that they want. And so you're going to want to put v here. Now this came from Niko. Niko, does it tell you what letter to use for? Well, I guess we can see it on the other axis on the graphs below. They use a t-axis. So we minus 362.5 t plus 1200. You guys probably already know this, but the WebAssigns, Pearson's, all these online things, they're very sensitive. Like if you don't put the right letter in, you'll get marked off for that. Okay, find an exponential model for the laptop. So that's part 2 of this. Do you know whether the you're using PAT or PERT?
Oh, we're using PERT.
Okay. All right, so PERT is fine. We can do that for part B. P is the initial amount, so that's 1200. So your V is equal to 1200 e to the RT. E is the exponential function, R is a constant. T and V are the unknowns. That's why you have that second data point. That's why you know that after 2 years, 475. So 2 is T, 475 is V. 475 equals 1200 e to the 2R. So I'd like one or both of you to solve this for R. And you're supposed to round it to 4 decimal places. And if you guys could chat me, one or both of you chat me that, I would appreciate it. That's the interactive part of our lesson today. We'll do more if we have time. Okay, Niko, you are correct, I think. No, you have an extra decimal place in yours, Niko. It's maybe
Oh yeah,
just typed it
there's
wrong.
there's no 0 there. Yeah.
Yeah. All right. So minus 463. So does it say to 3 or 4 decimal place in the problem? 4. You guys getting me 4? What's going on here? Is it 4? 4, 3, 4. There you go. Okay. So your final answer, you're putting this number in here. So it's V equals 1200 e to the minus 0.4634 t. Anything you'd like me to cover again on that? Good. Okay. So to determine the graph, one of the, do you guys ever get multiple choice graphs in your exams?
No,
Probably
we have
not.
to make them usually.
Yeah. So one of the reasons they're giving me this problem, they're trying to emphasize like, hey, if it depreciates linearly, like at some point the computer is worth negative, which is ridiculous. So these actually you guys should know better than this in your math level. Like this is unreasonable, that part there. So they all have different places that they cross the x-axis. So if I were trying to choose this one, I would just solve the first one, see when it equals, when y equals 0, I would go up to this equation here. And I would set it equal to 0. and solve for x or t. And you're going to get something a little bigger than 3. So it's probably letter D. And then we could talk about how to graph the other one if you guys think you would need to do that. So t is approximately 3.3. It's probably letter D. Or yeah, I don't know, this one lower right. Any questions on that?
Oh, that's perfect.
All right, let me jump over to James. Jamie, I'm sorry, I don't know what to call you. You can tell me if
Go by Jamie. Jamie's one.
Jamie, fine. Okay, thank you. You have a problem here about atmospheric pressure decreasing with increasing altitude. I'm seeing that you sent one of those. I think
Yeah.
Niko had the same question. I'm going to use yours as a baseline here. Let me snip that in. A lot going on in this question. Okay, so they give you a data set. The interesting thing here is that, and you got to be careful at this, they sometimes give it to you out of order, like this is really the Y column and this is really the X column. Just the way they do it in this thing here. They want you to make this kind of regression, which is maybe something you guys haven't seen until this class, or maybe you didn't even see it in class, but they want to do it for the natural log of P, not P itself. So you have to take the natural log of P. You need another column with those values in it. Okay, so I'm going to pull up the calculator. I assume you guys are doing all this in your calculator in your class.
Yep.
Yeah.
Okay. Have you seen this before, or is this totally new? New?
I think a little new, yeah.
Okay.
Don't know if I see that.
Let me get my calculator out and try to make some sense of this for you guys. So hopefully you have this data set up, and then I'll switch over to that. All right, so you guys are seeing my screen, my calculator?
Yep.
Okay, so we're gonna go to second list, L1. Nope, that was wrong. Second list, stat, edit. Okay, so it's stat, edit. All right, there we go. So we're gonna put the p-values in L1. Okay, so we're gonna go 1. Boy, this is so slow. 0.55, 0.25. All right, now this used to be really a cool feature, but like you guys, like we're used to phones and computers, but like it used to be really cool that you could do you could evaluate on all the data. So this L2, what you can do here is you can actually type in LN, and then you can grab list 1, that's second, the number 1 button, and it'll take the natural log of all those numbers.
Could you repeat how to do that?
Say that one more.
Could you repeat how to do that? Sorry.
Yeah, let me go and clear it out here. So another way to clear out a list, this is also important, is you hit clear, enter, and it clears it all out also. So you go up to L2, and my cursor's kind of like, it's showing you like, hey, you can enter a formula for L2. So that formula for L2 is LN, second 1 to get the L1. So you're taking the natural log of everything in L1, and then you hit
Okay.
enter.
Thank you.
Jamie, how is that for you? Is that clear?
Yeah, that makes sense.
Do you think you could do that on your own?
Probably, yeah.
Okay. L3 is now the Y values. So the Y values are 0, so on here, and I got to enter them this way. Okay, so I've entered my data. Any questions on this?
Nope.
X is in L2 and Y is in L3, because what I'm calling X is really the natural log of P, because that's what it's asking for. If you look in the problem there, it's asking for natural log of P is taking the role of your variable. So second quit, and then you go back to stat, calc, linreg right there. Sometimes there's some confusion about this one versus, I don't know, one of the other ones on here. It doesn't matter. Like, it really doesn't matter, but just like whichever one you use is fine. Let me use that one. Oops. Oh, this is the old style. Okay. So I think I have to actually tell it like which one is X, and X is in L2 and Y is in L3. I don't know if this is going to work. Didn't work. Your guys' calculator will probably tell you, like, will ask you like which one is X, which one is Y. It'll say like it'll give you another screen here that this one's not giving me. Second, L2, I bet I have to put a comma here. There it is. Okay. So you guys, you're trying to determine these parameters here. So these are slightly backwards from what you have, because this is AX plus B. Yours is A plus BX. So anyway, in short, like B is really your A. Your B is 0.8627. I'm writing that down on the notes here. And then plus your B is minus 6.4474 natural log of P. Is there anything here you'd like me to go through again?
I got values that were very different. Is that a problem?
Yes, because you likely did not use the right lists.
Got it.
So your calculator will by default try to use L1 and L2 if you don't tell it. You want to use L2 and L3. So if you don't like this business that I did here, another option is to like completely, like, you can do some things here, like we can make L1 equal to L2, but I wouldn't do all that. I would just learn that it's like L2 and L3. Another option is to enter the natural log of the numbers in L1. Like, instead of 1, put the natural log of 1 into the calculator, natural log of 0.55, natural log of 0.25, and so on. Any of that, is that clear or is that not?
That makes sense.
Okay, Niko?
Yeah, that makes sense to me.
Okay, so like, I'm concerned that you guys got to be able to, and the really the one I should have had you use here is this linreg A plus BX. And then in mine, yours has arguments, like yours is like independent or dependent or X, and you want to make sure you choose L2 and L3.
Oh yeah, I had L1 in there.
Yeah.
My
Okay.
bad.
Okay. So is that part clear? Because I'm going to jump back to the other window for now.
Yeah, that's clear.
Okay. Let me get that up. Boom. Okay. So wrote down your regression equation. There it is. I really hope this is right, because everything else is based on that. Use the model to estimate the altitude at which the pressure is 0.866 atmospheres. So that's saying that that's your p-value. So for part C, you're going to put 0.8627 plus negative 6.4474 natural log of P in there.
Yep, that's right.
All right. And then for part E, it wants you to go the other way. yeah, I'm sorry, part D. Part E, they're giving you the H value. They're saying 7 equals 0.8627 minus 6.4474 natural log of P. And then you subtract 0.8627 from both sides. I get you your final answer. So it's 7 minus 0.8627 all over negative 6.4474. And then you take the E of that. This will want to be in parentheses there. .8627 divided by minus 6.44. All right, so I get 0.386 for part E. So we did this for Jamie. Niko, did you have different numbers in yours?
Let me check. I think so. Which number is it again? I think it's,
You had different numbers for part D and part E.
yes, everything else is the same though.
Are you comfortable doing those on your own?
Yes, I think I can.
Okay. All right. So now, Jamie, that covers all the, no, Jamie, we're going to do more of yours. It's more graphing stuff here. Oh, I see. It's just the continuation of that problem. All right. So new problem here with another data set here. Let me snip that in. All right, so year is typically T or time, but it tells you that T equals 5 corresponds to 1995. So I would encourage you to like either rewrite them somewhere, 5, 6, all the way up to
Yeah.
whatever it is, and just not do that. So you're going to want to grab your calculator, and we're going to do each of these regressions. So I'm going to share that screen. Do you guys have your coefficient of determination enabled? Like when you did the regression, did it give you R and R squared last time?
Yeah.
Okay.
Yes.
Mine does not, so I'll have to enable it, or just you guys can write the numbers down. But let me get that up again. New share. There it is. All right. So as a reminder here, because this is really important here, like sometimes you get this data in your calculator, and you're like, what do I do? You don't want to reset the memory. That's like, resetting your phone for, to delete a contact. It's ridiculous. You have to go up to where you're highlighted on the L3, then you can hit clear, enter. And then you want to do the same thing in L2, clear, enter. I don't like to overwrite the data. Sometimes you make errors just forgetting, keystrokes, stuff like that. So we're doing 5 all the way up to, I don't know what we're going up to, 2009.
Like 14.
Yeah, that seems right. We can always delete them if we got too many. Okay, so then you go over to L2 and you enter the data in. Have you guys already done that? I mean, this is not hard, but you're going to be graded exclusively on whether you actually enter the data correctly. So I would double check this. If it were me on an exam, I would scan over it. One of the things that I do is I enter it from top to bottom, and then I check it bottom to top. And that trains your brain to not look for the things you already saw. All right. So now that I got that data, so to do the quadratic regression, you always want to quit out of this. If you start trying to do something in that window, sometimes it'll actually enter data, stat, calc, and then you got your 4 options here. We're going to be doing quad, exponential, and power. So we're going to do quad reg. Now, because your data is in L1 and L2, you don't have to do it. You can just choose the defaults. I have to actually enter L1 and L2. Okay, and you have the regression equation here. So I don't know how many decimal places to watch around to.
It's 3.
3. Okay, so I'm gonna write those out on here. 0.014 x squared. Sometimes these have like they say 10 e to the something. You just want to make sure that you, and that would be on the right hand side. This one doesn't look like it's got it. These numbers look better than before. That was directed at you, Jamie. I think this was came from yours.
Oh, sorry. Can you repeat that real quick?
Yeah. Do you have does this look better than before? Like these numbers that I just showed on the screen. What did that look close to being right?
What was weird was I have these exact same numbers earlier and tried it, but it didn't. It said it was wrong.
Okay. That's bad.
But the
Maybe,
regression,
maybe use
regression was right.
what was the variable on the t?
Shoot.
You need to use t.
Yeah. I
And
used X. That's probably why.
that's probably why. Let's see if I can get this. Yeah, there you go. Okay.
I don't have the R squared on mine anymore. I don't know what happened, but it's just gone now.
Okay, so here, that's what I was asking. So to do it, you have to go to second catalog,
Yeah, it's right now.
and then you go all the way down to diagnostic on. And there's two options. There's diagnostic off, diagnostic on. This is kind of like the registry in your computer. If you ever played around with that, maybe not, but the diagnostic, you have to hit enter and then hit enter again, and it'll say done, and then it'll appear.
Thank you.
And I forget that, so I have to look it up a lot, but you might want to make a note to do that. Okay, exponential regression. So your calculator was designed before some of these like more common words are used. So you got to be careful here. Exponential regression, if I hit enter, and shoot, I got to do this L1, L2 again. Can't believe. Okay. You have to look at the output. So this is a b to the x. So I think this is what your instructor actually calls, this is actually power regression, because power regression is a b to the x, and exponential regression is the p e to the rt. And your calculator just does it backwards from what you think is right. So just be aware of that. It's just an oddity. And regression. I'm writing these numbers down in case, in case you don't have them. And then you go stat, calc, and then power regression. Oh, I gotta enter these again. L1, comma, L2. I think this gives it to you. No, it doesn't. I'm wrong. What I just gave you is exponential. I think you may have to convert it to E form. I can help you with that if that's wrong. Let me write this down, and I'll go back to the other window. So the power regression 1.480 times x to the 0.379. And then this is 0.98961. Okay, let me share my other screen. I think this will make more sense when you see this. Oh, this is a T. This is a T. Okay, if you're seeing my screen, Jamie, like I guess the one I'm not sure about is this middle one. Your calculator gives you exponential. Your calculator thinks exponential is pat. And WebAssign probably wants PE to the RT.
Yep.
Now we can actually do this, okay? And some books actually have you do that. So to do it, the first number is the same. It's always 2.296, but we basically convert 1.042 needs to be equal to E to the R. So to do that, you have to just take the natural log of that number. Now, I don't think we had enough decimal places, so let me go back and grab that screen. That equals R, or T. So the number, sorry, I'm bouncing around here a little bit. You want to enter 2.296 E, and then I'm trying to get you that number here. And the natural log of 1.042 might work, might not be enough decimal places.
Okay.
Though, so try that or don't try that. Let me know. So to answer part C, you want to determine which has the biggest coefficient of determination, and it looks like it is the quadratic regression model. I think you already knew that. Part C is the quadratic. It's whichever one is R squared is the biggest. All right, part D. Part D here, to do part D, we can do this in a list, if that's okay. I'm going to jump back to the calculator and show you how to do this.
Hmm.
This is the fast way. You can just enter it, one by one, but I'll show you this in the calculator. Maybe you'll find it useful.
Right.
All right, so I'm going to go stat edit. So I already got my L1 and L2. Okay, L1 are the ones that we want the values of. It wants 5, 6, 7, 8, 9, 10. So I'm going to go to L3. I'm going to go up to L3, and I'm going to enter the equation that we have from part A, the model. So the model is minus 0.014, and this is where you have to hit second L1 squared, because you're choosing the value in L1. So L1 is like your X or your T, plus 0.396, again, L1, because you're grabbing the value from L1, plus 1.009. So this seems like a lot of work maybe, or you're like, why would I do that? The power is that it gives you all the values at one time. So if you don't like that, you can go do it from the home screen, but that will give you the results there. So I'm going to write the ones down that I get from this, and then I'll jump back to that other screen. So 2.6. Okay, that takes us through what we got. I think what you both sent today. Is there some other things you guys would like for us to work on?
I think I'm okay.
Jamie,
Good.
how about, this might actually be useful. Is it okay if I give you a question of the week, or we can end here? It's up to you guys.
Yeah, I'll do one.
I'm good with a
That's fine.
question of the week.
Okay,
Yeah.
let's try it out here. Okay, so if you can, chat me your answer. It is not recommended to guess on this one. So give you take at least 60 seconds and or more, and then we'll talk about how to do this together. Jamie, how much time would you like to continue working on it?
I think I made a mistake somewhere, so
Yeah,
I'm good with.
me too.
Sure. So you guys are probably used to like this form, which is vertex form.
Yeah.
Problem is I don't give you the vertex, and maybe you could guess it, maybe you can't, but you know, there is actually enough information here. These actually go by one. But that's actually not the way this question was designed. The other way you can do it is what you see more common for polynomials. I mean, this is a polynomial here. So you can actually do it in this form here, this factored form, believe it or not. So there's a 0 at -2 and a 0 at 3. So y equals a, x plus 2, x minus 3. To find a, you need an x and a y, which is why you're given this. So 12 equals a, 1 plus 2, 1 minus 3. So 12 equals a times 3 times -2. A equals -2. And then you put that back into this line, and then you can try it at -4.
Got
So
it.
you get y equals -2. It's a spin on always writing it in vertex form, which you may or may not do. So this is -2, this is -7, this is -2. So you end up getting -28, letter D. Would you like to do another one like this?
Yes.
Yeah.
Okay. Now, if you solve it the same way I did, the goal now is to say, okay, I'm going to try and do this in a certain amount of time. So let me snip the question in, and guys can do that.
Okay.
Okay, Niko, you are correct. I'm sorry, Jamie, you are correct. It looked the wrong message. Oh, and Niko, that was the second message from you, I guess. Yeah, that's correct. All right, great job, guys. Thanks again for scheduling. I'll send you the notes and the screen recording out shortly, and I'll see you guys next time we have a lesson.
Awesome. Thank you.
Have a great day. Bye now.
Bye.
Thank you.